let us see how we handle this number here. It says particles P and Q are moving with constant velocities of, so these are the velocities, meters per second. Initially, the position vector of P is this, so these are the position vectors. For P is that, and then for Q is this. Find the velocity of P relative to Q. So these are the velocities. So the velocity of P is this, then the velocity of Q is that. So in simple terms, in part A, they want us to get the velocity of P relative to Q. This one is given by velocity of P minus velocity of Q, which will be the velocity of P is 3, negative 2, then minus the velocity of Q, negative 1, 4. Okay, so from there, it's that our P relative to Q is going to be, that will be 3 minus minus, give us a 4. Then negative 2 minus 4, that will be negative 6 meters per second. So that's part A. Then part B, show that particles will collide. Show that particles will collide. We need to show that. Remember, we said the relative velocity is always parallel to the initial distance, which we are going to say is going to be relative to P relative to the displacement of Q. As simple as that. So we have this, then we need this here. So our P relative to Q is going to be our P relative to Q. We shall get the displacement of P n minus the displacement of Q. Okay, so we are going to get our we shall come here and we get our 1 of 5, then minus 3, 2, and this will give us 1 minus 2, that's negative 2, then 5 minus 2, that's negative 3. Okay, so if that's the case, that we have, sorry, this is negative 2. Yeah, that is negative, sorry, this is 3. The rest is, then this is, yeah. So this one, when I get that is not the case, sorry. Okay. Our Q, which is 2. When you simplify 5 minus, that we are getting there a positive. Sorry, here we are getting a positive. So that will be positive 3. So after simplifying that, 1 minus 3, we get negative 2, then 5 minus, get that. So there, you can see that this is our P, the displacement of P relative to that of Q. Now, what do we see? Oh, we need to show that this one is parallel to this. But when you come to this and you come to this, but our P, the rest of P relative to Q was 4, negative 6. So you see, what do I need? You see this is negative. So if I factorize out negative 2 in there, we are meaning with negative 2. And when you get this negative 2 divided here, get this negative 2 divided here, it will be a positive 3. And from there, I think you can see that this is our, so that our PQ is going to be negative 2 into now the whole of this, which is P relative to Q, and therefore negative 2 P relative to Q, and this shows notice that the particles will collide because these are parallel. As long as the resultant vector is parallel to the distance, then that is going to be the case. So it's that this one is parallel. So our k is -2. So that's what we had to show. The moment the theory that show that they will collide, or it show that the relative velocity is going to be equal to a certain constant, that of the resultant, the relative displacement, as we seen there. Then so the time when they collide. So we said our time of collision is magnitude of the displacement P relative to Q over magnitude of their relative velocity. So we can get the magnitude. So magnitude of P relative to Q is going to be the square root of, we come to -2 squared plus 3 squared, and this will be, this is 4 plus 9, that would be root 13 meters. Then when you come to P, Q, this is going to be the square root of, we have 4 squared plus -6 squared. This would be 16 plus 36, which will be 52. Yeah, 52. But this is velocity, meters per second. So our time there is going to be root 13 divided by root 52, which will be, you put them under 1, 13 over 52. I think we can see that 13 goes in 52 4 times, which is going to be, so our t there is going to be a root of a quarter, because this goes there in times. Or you can see that 4 is in here. So it's up to you. So our t now is going to be a half, which is 0.5. Now these are going to be seconds, and that will be the time. So that's how we handle this number. I wish you well. So then the moment you hear the word they are telling you, show that they are going to collide. When they are giving you this form, just get P, B, Q. Initial, these are initial. This is the initial positions, as simple as that. So that's it. I wish you well.